Hello everyone and welcome to my presentation on documentation for brownfields. I'm Nicola and I'll be guiding you through how I created documentation for my project. Let's start and show you the README. In the README, we have completed all of the above, which is refactoring existing code base and addressing hotspots and adding acceptance tests, creating build scripts for compiling, testing, and packaging the code, integrating code changes, and building a pipeline, improving the architecture and adding databases, and implementing the API to make data easier. We also use ORM mapping for data access. These were all completed. We have the original team, and then we have the team that we did. We have versions for testing. And then we'll move on to the curriculum site, where we got the pre-design. This was where we saw what design to follow and the features we needed to add. As you can see, we have brownfields, an explanation of all our iterations, and what we do in robot world, which we did in the previous project. And here we added the acceptance testing, pipelines, databases, and the change to architecture. And this is just the explanation on the documentation we had to follow. Next, we'll go into Git issues. So this is one of my favorite parts of the project, as this is the documentation that I believe is the true one, is going through everything that we had to do in brownfields, code base, and what we had to add. So for refactoring, we had to rewrite these problems that were wrong with the original code base. Up to I think here, yes, and these were the hotspots we had to get through. And in most of these are little stories of what we had to do. Let's go in here, and yes, these are, as a player, I want to launch a robot, and that was the launch command. And next, I will show you our doc strings. There we go. So doc strings are important where you're refactoring and anyone that can read your code base. Here we had the fire command, which was one of the hotspots. They had called a shoot, and we just explained what we were doing. I believe that in computer programming, documentation at every turn is very important. And when you're working on a code base, you have to have comments and doc strings, because you never know who's going to work on. You never know who's actually going to work on it and know what mindset you are on when you wrote that. Even if you write something, you should better comment, as that's the documentation you're going to be following tomorrow. And then here is our biggest code hotspot. We couldn't change much of it because we didn't want to change blocks of the original code. And this is what I mean by documentation. Here we have a summary of all the changes and the handle command, and we have more blocks. And then even in our tests, we have our comments. The reason, as I say, is documentation is very important, because in the industry, you have to be able to know what the person before you was thinking or what you were thinking the day before, for maintenance and refactoring purposes, which are very common. And thank you so much for joining me.
Hi, I am Bliss City, and I will be sharing about the software development source files. So, I'm using POM files here. POM files specify the project coordinates, which is the group ID, the artifact ID, and the version, which uniquely identifies the correct source file associated with the project. The dependencies section lists the project's dependencies along with their respective versions. Like this ensures that the correct version of additional files, which are your external libraries I meant, or modules required for the software development, are identified and utilized. And then we have the GitLab CI/CD configuration file. Yeah, defines a pipeline with like 2 stages. There's a pipeline. Sorry. So upon like each commit or match request to the repository, GitLab automatically triggers the pipeline, ensuring that the source files are retrieved and processed through defined stages according to the procedure. The other stages, which is the build, the test, and the deploy. Like what this does, this process helps maintain the consistency and ensures that source files are continuously updated and integrated into the project's workflow. So since the pipeline failed, they are not being updated. Let's say, oh yeah, look at here. You see the build passed, the test passed, and the deploy passed. So which means that this database separated from server will be updated into the project's workflow, and then the update GitLab CIYM file wouldn't be updated into the workflow. So like each commit to the repository, like it creates a snapshot of the source file, preserving their state at that point in time. If updates like causes issues, then we can revert to previous commits. Like suppose this one, the cleanup has issues, then we can revert to the previous one. And recover lost changes. Also, GitLab allows administrators to determine who can push changes to prevent unauthorized modification and ensuring the integrity of the source file. Git branching and merging helps manage the concurrent changes. For us, we created branches to work on specific tasks like independently, reducing the likelihood of conflicts with changes made by us, like, or other team members. Like, yeah. When we were ready, we matched back into the main through match requests, allowing for review and conflict resolutions before integrations. So, yeah, this is about software development source files for our project. Thank you.
Hi guys, my name is Khalisom and I'll be doing section B for Brownfields. So I'm actually using my phone to record everything because my laptop, the speaker doesn't really work, so it's kind of useless. You won't be able to hear anything. So yeah, I have notes written down so that I can be able to not forget what I have to say. It's not actually notes, it's like what key points of what I should be talking about. And then what's this? I'm gonna try to put screenshots of everything that I'm talking about at the top, since I can't really screen record, you understand? I'm gonna try that and then hopefully it works. Okay, so the code specific, basically Brownfields, right, is all about refactoring an old code and maybe optimizing it, like optimizing the features and adding new features, and yeah, try to work on the outdated systems and basically just bring new life to the code. Understand, like the code should just be a breath of fresh air while using an existing code base. Understand? Okay, so the code specifications included but not limited to the client should be able to start a server, and client should be able to join the server as a robot, right? And then in our code, clients are able to move and change direction of the robots. Clients should be able to defend themselves from other robot attacks, yeah? And then the client should be able to also attack themselves from other robots, right? And then yeah, that's what it basically does. Yeah. And then the data accessing methods, it's like there are 3 of them, right? So it's data access and database management, and then there's data transfer, data access and data transfer. It's actually in my mind like I get creamy like a bit, right? And then there's data access and file management, right? So I'm quickly just gonna explain what they mean, right? So I think I started with data access and database management, right? So basically them using JBDC package to establish safe data access, and then the data transfer is utilizing principles of value pairs and accessing data. And then the data access and data file communication is using inheritance, composition, and polymerization in Java. That's what they use. I'm not really sure about the name. And then the coding, the naming conventions that we use, right? We went with something very simple, something if maybe someone who doesn't understand, someone who doesn't know how to code, or someone who didn't really write the project can be able to understand what I'm talking about. You understand? Like keep it very simple, very simple, so that another person can be able to understand, you know, like yeah, understand what I'm talking about. And then for the documentations, right, I think the design documentation, I think this is where I need to put those slides at the top. And then yeah, I'll just try. And then I feel like I'm leaving something behind. Okay, I'll just skip to testing, and then I'll try to remember what I left behind. So testing, right? We have, I think, 4 different types of testing, and I feel like, no, I don't feel like the reason why testing is so important is because to test your code is so important because you can be able to, if there are any errors that occur, it's gonna help it, you know, when you have test cases, you'll be able to see, okay, maybe this thing is not working because of a certain error that's there. So that kind of helps, you understand? So there are, I think, 4 different types of testing, but I'll just name the ones that I remember. So the first one is unit testing. I think that's the most basic one. And then there's acceptance testing, right? And then there's functional testing. Okay, I might have to look here. Okay, I can't remember the last one. And then yeah, what else am I leaving behind? I feel like, oh, the last one is integration testing. Yeah, integration testing. So I feel like that's it. I'll just have to put screenshots of everything that I'm talking about on top. I'm not sure if I can be able to do that, but yeah. Then yeah, thank you.
Hi everyone, welcome to my Brownfields Development presentation. My name is Lumile Makalima, and I'll be focusing on section C, which is database management system. Now, the goal of the project was using an existing code base to change the design of the system or add new functionality by using build pipelines, databases, separation of concerns, and so forth. Now, our goal as a group has been to enhance the functionality and efficiency of our application through the implementation of a relational database. Now, let's dive into the specifics of our journey and how we've leveraged database management systems to address our data management needs for the project. Now, research and choice of database management system. Firstly, we've embarked on comprehensive research into computer database management system and make an informed choice. We selected a relational database management system because of its robust features, scalability, and compatibility with our project requirements as stated in the Within Code curriculum. And then moving on to the data management issues as well as solution. We've identified several data management challenges such as integrity, concurrency control, and data security. Relational database management system that we've chosen addresses these issues through its support for ACID transactions, role-based access control, and built-in mechanisms for validation. And then moving on to the features of commercial database management system. Our chosen database management system offers a plethora of features such as indexing, query optimization, and data replication. These features contribute to efficient data retrieval, improved performance, as well as data redundancy prevention. And with regards to types of database management system, we've explored various types of data management systems, including relational, NoSQL, and NewSQL. Now, each type has distinct characteristics and use cases. For instance, relational databases excel in structured data management, while no SQL databases are optimal for handling unstructured data, which was the motivation for us to choose a relational database management system. Database management system end user tools. Relational provides user-friendly tools for database administration, query writing, and data visualizations, and these tools empower users to interact with the database seamlessly and efficiently. And moving on to the next slide, choice of justification. Our project necessitates a database management system that could accommodate complex data structures and provide reliable performance for our project, and relational database management system perfectly aligns with our database access requirements and as well as critical performance factors. Moving on to the showcasing the database for our project. We've meticulously designed our database structure to meet user requirements, ensuring each table adheres to the third normal form. Our database caters for robot world's data needs efficiently, with key relationship between tables and clearly defined. And throughout the project, the design, primary and foreign key consistency is maintained to ensure data integrity as well as relational accuracy for our project. And in conclusion, the integration of a robust database management system into the robot world has significantly enhanced our application's data management capabilities, and we are confident that our choice of relational database management system will continue to support our project as well as its scalability. And this brings us to the end of the presentation. Thank you so much for watching, and yeah, that is all. Thank you.
My name is Renai, and today I'm going to be presenting the SQL and data implementation for our Robot Worlds or Brownfields project. So please enjoy. First and foremost, so for our database, we wanted to use SQLite and EOD SQL because it allows for fast and simple binding in a relational database. And also, like, the queries and Java objects are very easy to manage. So that's why we opted for EOD. Let me show you here. So first we imported the EOD SQL. So first we start by importing the net.limnic EOD SQL, the base query. All right. So this is where we insert into our worlds. We insert the type of world, the world size, the world dimensions, and what's happening with the world, and the world name as well. And we add that into our current database, which is not there. So it's going to create one because there's no database there as of yet. And we also insert our objects, for example, our pits, our blockades, like our objects, obstacles, and everything like that inside of like the world that was chosen. Also with their coordinates as well. So we add them. Yeah. As you saw, we have we have two different queries for inserting into the world, inserting data into the world, one to manage the world and the other to insert objects into the world. which were these two right here. They create the table, and yeah, they take the data from our robot world or robot worlds and objects and put that inside of the database. Moving on, we had 4 select queries in order to manage the world ID, the world data, the obstacles, and such, so that like the actual world can be recorded inside of the database. Let me show you here. So we have one for selecting the world ID. There's another one to get the world name, another to get the world size as well. Yeah, then we also update our values every time a change is made, if the admin allows it, so that like the data can be saved inside of the save command. We call it here because we access the database URL using jbdc.sqlite. Of course, we had to have the query tool so that like we can upload the queries and all that. And also we also import the robot world DAI so that we can access these tables and update them. So there, we save the data, the database here. From here, sql.data.sqlite. Yeah, getting the obstacles, the world size, the pit list, the mine list, the obstacle list. These are like the different obstacles or objects that are there that are implemented into the database. And we have confirmation saying, okay, obstacle was saved. So we save those into the database. Yeah. So yeah, I've already explained this. We import it inside of the save command and the restore command so that like the database will be able to be saved just in case something terrible happens or like all the data is lost. So we have like a backup of the data so we can use it to restore the world and such. Save command. Here's the restore command where we call the robot worlds DAI and the query tools so that we may manage the data. The disk UAV JBDC, this is where we're accessing the tools and the database URL. And this is where we get the connection, get the values of our saved data that we had in outside of our save command. The world size, the obstacles, the pits, the mines, these are the different types of obstacles that were saved inside of the database. So, and then say for example, our database, no, not our database, our code base, something terribly wrong happened, like a common thing in South Africa, like load shedding acquired while like the game was still going, and then like the game shut down. So the data would have been saved for us to be able to restore it the next time the power comes back on. Unless if there's no data, because we didn't save the data inside of like the save command and all that. So we save the data and everything else. Just gonna go through the code to show. Yeah, this is where we retrieve obstacles for the database for like the given world. And this is for the world size. And this is the world name. So inside of a world name, we have the world size and the type of obstacles inside of that world. So that data is recorded so that it may be restored at a later time. So the purpose of the data, the purpose of the data in the project was to learn about SQL and data management. However, what I think is the most important thing for having data or having like a database in the background or URL is so that like the data can be saved. Like I said, in case of an emergency where like one device crashes and then like this the data is becomes corrupted, and they're not able to like go back into like the data that was stored inside of the project. So they can hit the restore since the data in there is saved and recorded. So I'll be going over the testing process for our project. So yeah, let's begin. So currently, we've been going through the process with test-driven development. So that's how we've been doing our tests and everything. As you can see, our tests are very easy to run. You just hit Maven tests. I'm gonna show those here. Extend this. Right, build successful. You can see that every test passes. Test run, failure 0. Yeah, so we have multiple ways of doing this. Either you can test through the command line, or you can run each test individually with the VS Code sidebar, where if you wanna check a certain test, you can run it. It passes. Example, you wanna test your minds, it passes. And then yeah, so even if we make changes like that are not there, that are not, if we're something that we're testing, like we change like what is not required, we change it to something that's required. If something that's not required is there, let me show you an example here. Let's do with pits. No pits found inside of our dump command. We change that, and then if we run our test again, it should fail. Maven test. Right, now we're getting errors because we have a failure. So even if you use the sidebar, it will show the failure, right? It shows that, okay, um, that there's a problem in our test dump objects. Of course, we changed in our dump command here. We removed a letter. So it sees that, okay, something is missing. You can use this sidebar to enter the test to see where it's failing or where it's not failing. Let me see if I can find the right. It shows debugging processes, no pits found, right? So it shows that there was a change there. It's supposed to look like this. It's what was expected, but it looks like this. Now, if you go back into the dump command and fix it, it will show that, okay, let's run the test now. It should fix everything, right? If we go into the terminal, Maven test, right? Now it compiles all the tests and they pass, okay? And as you can see, the tests are repeatable. If I run Maven test again, just to show that's not a fluke. So yeah, we use test-driven development to create our tests. So we create our tests first, and then we use those as a guide into the coding process of how what we want each section of the test to do or whatever we're working on. Yeah. So we communicate with our teammates to be like, okay, I want to change this. So first we're gonna have to like create a test for that first, and then we're gonna test it. Like for example, in terms of creating pits, let's say, okay, we're testing whether the pits are generated, right? We're testing whether the pits are generated, and then let's say you want to change some stuff here. You write some tests or add tests, right? You add your tests because test driven development with add test. uh, let's say test pet does not exist. Oh yeah, please use the Pascal thingy because it's Java. Right, so let's say you want to create tests. So that's how, damn it. Public. Sorry, I'm a bit nervous. Yeah, you want to create test and then you write the dimensions of what you want your test to be, and we communicate over it, and we write it down inside our Git boards that okay, we changed this, we aiming to change that, and everything like that. So our tests are repeatable. We communicate as a team to be like, okay, we need this. Can you create a test for that? And then we do that each and every time. So yeah, for our test, we call the test in our test main. So these are some of the tests where we have a test that check the robot, like for example, the world size, the type of robot that we used for our Brownfields project, and also the database. The test include the test for the database to see whether it works. It also creates a mock server, right? It creates a mock server it's like a dimension for the test to run, and then the server stops immediately after testing, so that like we don't have like port issues or failure issues as such and such. So yeah, that's gonna be it for our testing phase of our robot world. So we don't really have like a test style. We're just following normal concepts of test-driven development, where we just test everything that like we're working on. And yeah, here's a test for obstacles where we're testing that okay, the path was blocked. Yeah, just to make sure that like everything works really. So we use our left side of our VS Code or IntelliJ. We make sure that like everything is up to standard with our POM XML file. Uh, since we're using JUnit test and Jupyter, we make sure that everything is up to date and ready and available for testing. So yeah.
Hello and welcome. On this part of the video, we'll showcase how our test plans have been executed, demonstrate our adherence to established testing protocols, and discuss how our database interactions are tested and optimized for performance. And firstly, we'll be looking at our test plan execution. Firstly, we'll start by reviewing our operational steps outlined in our test plan. Here you can see how we planned and the corresponding execution on the system. Demonstrated in front of you is a story that we written and the aligning acceptance test which are written as exactly as part of the story is required. You can notice how we input the specified data from our test plan to validate the functional requirements. And secondly, we will be looking at handling deviations. During our testing, we encountered a few deviations from our initial plan, primarily due to unforeseen system behavior under edge cases. And here is how we address these deviations. Adherence to standards. We strictly followed the standards and procedures for testing and retesting as specified in our test plan. And we had principles and practices to follow. These are a few important principles and practices to keep in mind when testing, implementing automated tests. is start testing first, and then you mock the external dependencies but remove the mocks if you can. Testing paths and database access. Each logic path in our code was meticulously tested to ensure it performs as expected, considering the interests of brownfield redevelopment. Here's how we tested our database access using SQL queries, focusing on our identifying errors and verifying adherence to our project's requirements. Verification of database function. We thoroughly verified our database function within the context of brownfield redevelopment, ensuring they operate flawlessly in the required environment. Here is how you can see the performance aligning perfectly with our project's requirements through the pipelines that we have created. And then documentation with the improvement and policy adherence. All tests were meticulously documented through a rigorous review process. We identified areas for improvement, enhancing the efficiency and effectiveness of our testing strategy for brownfield redevelopment. Our adherence to organizational policies ensure the robustness of our testing approach. And in closing, this concludes the demonstration of the testing process tailored for the Brownfields development by showcasing our meticulous test plan, execution, and database access verification. We've ensured the integrity and reliability of our project.